Hi everyone, welcome back. So in this video, we're going to look at a final scenario where resonance is possible. And this scenario is when we have double bonds and alternating actually double bonds within a, and I'm going to make it a little specific, 6-membered ring, okay? Because it doesn't necessarily work with rings of any size, okay? So we're going to talk about a 6-membered ring specifically here. So the example here is a benzene ring. So this is a benzene ring. And what we notice here is there are alternating single and double bonds here in the ring. So there are 3 double bonds and there are 3 single bonds. So in a scenario like this, again, keeping all the octet rule and connectivity in mind, in such a scenario, you can start with any pi bond. So let's say if I start with this pi bond and push it to the space between the other carbons, and in fact, I'm going to number carbons here. So 1, 2, 3, 4, 5, and 6. So I took the double bond between carbons 1 and 2 and pushed it to the space between 2 and 3. And if you do electron count, what you would realize is this is going to increase the octet or exceed octet for carbon number 3. And so what you do is at the same time simultaneously going to push the double bond between 3 and 4 to the space between 4 and 5. And if you just stop over there, then that exceeds the octet for carbon number 5. So we're going to do one last push. We're going to move the pi bond between 5 and 6 to the space between 1 and 6. And so this would give us a new resonance form where we have double bonds between carbons 2 and 3, 4 and 5, and 6 and 1. So the double bonds and the single bonds, in some sense, they swap places or they switch places in some sense, okay? But that's not what's happening here, okay? The electrons are delocalized, so they're moving around, so that's what's happening here. Now, I think this is a great example to also talk about resonance hybrid. I think simple and complicated to some extent, straightforward and complicated at the same time. So I'm actually going to talk about resonance hybrid here. Again, this concept was mentioned in the introductory video, okay, in the introductory example. So we're going to talk about resonance hybrid for this structure or for these resonance forms. And a resonance hybrid, if you recollect, it captures scenarios or the bonding from both not both, all contributing resonance forms, okay? So it's basically capturing the electron distribution or the bonding from all contributing resonance forms. Now in this particular case, we only have 2 resonance forms, so that's why it's sort of easy. Now, so when we're drawing a resonance hybrid, what we have to do is, the first thing to do and the simple thing to do is to actually draw the skeleton, which is all the single bonds, because sigma bonds or single bonds, they are not affected by resonance. So let's go ahead and just draw everything that does not change between these 2 resonance forms. So what would you say did not change between the 2 resonance forms? I think the ring itself, okay, the 6-membered ring, that never changed between the 2 resonance forms. So let's go ahead and draw a 6-membered ring. And so once we've drawn that skeleton, which did not change between all contributing resonance forms, it makes things easy. And since we've already numbered these here, I'm also going to number the atoms in this ring. Okay, so if numbers. Now, if you compare the two resonance forms, or if you have more, you're going to compare all the resonance forms. What you would notice is there is a double bond between carbons 1 and 2 in structure 1, but it's only a single bond between carbons 1 and 2 in the second resonance form. And so to capture this, we're going to say that, okay, the average of a double bond and a single bond is 1.5 bond. So we're going to put a dotted bond between 1 and 2. When you look at 2 and 3, again, there's a single bond in one resonance form, double bond in the other resonance form, and so a dotted bond there. And what you notice is the same is true for each set of bonds. So basically what that means is there is a 1.5 bond throughout. So once we draw that dotted line in, we've got the resonance hybrid for this structure. In fact, what you would realize later is that this resonance hybrid, okay, these dotted bonds, 1.5 bonds, are actually represented by drawing a circle throughout. So that circle is basically saying that the electrons are spread all over, for all of these atoms, okay? The electrons are spread, so that is the resonance hybrid for a benzene ring. Okay, so I thought I'd bring that up because it is sort of complicated, but yet simple enough structure, to point this out. Okay, so that's all the criteria that we need to keep in mind when we are drawing resonance forms. In the subsequent videos, we're going to talk about the relative priorities or the relative significance of these of various resonance forms. Like, so when you draw several resonance forms, which one's a major contributor, which one's a minor contributor, which one's important, which one's not that much important. Okay, those kind of things. So we'll discuss those in subsequent videos. Bye.